Welcome back. We spoke about circles. We're going to continue talking about circles, and we're going to be doing some examples. So let's turn to the board. Here we can see the content map. We've still got all of those things that we did discuss, but we're going to continue with the circles that we were talking about. So here's our first example. It says a circle with center 0, 0, and so I know that this is at the origin. So all the circles that we've looked at so far have had the circle center at the origin, passes through the point -3 and 4. And as a first question, and there's going to be a second question as we go on, but they want us to sketch this circle. So our first step is just going to be to draw our Cartesian plane. It's going to be to put the center in. It's going to be to draw the points -3 and 4. And in this case, we don't have to use any sort of geometrical kit to do this. We can just do this in freehand, and there I have my circle. I've drawn it on my computer. It looks much better there, and there we have our circle with that point and our center right in the middle of the Cartesian plane at the origin. Our second question for this same set is to find the equation of the circle. Now, I'm going to move the sketch to the top in the corner there, so we've got a little bit more space. Exactly like when we were talking about our straight lines, what's so important is that every time that we start a question where it says find the equation, I always want to write down, well, when we did the straight line, y equals mx plus c, because that's going to help me know what must I find. I must find the gradient m, and I must find the y cut c, and that's what we're going to be doing here. Every question where it says find the equation, I'm going to write down the form of what I'm going to be finding, and in this case, it is x squared plus y squared is equal to r squared. Now, all I need to find now is the radius. So let me actually change the color of that. Let me erase it, and let me go change the color to blue. So then all I need to go find is the radius. So I need to go find that radius. Now, I don't know if anybody has got any ideas about how to do this. How do I find that radius? Well, what is the radius? The radius is just a length. It's just a distance. And so if I need to find a distance, what am I going to use? I'm going to, well, the formulas that I know is gradient. I know the midpoint formula, and I know the distance formula. And so this is what I want you guys to do. Every time that you have a question in analytical geometry, take out the formula sheet and decide which formula am I going to be using, because specifically for analytical geometry, it's very formula driven. All right. So in this question, I need to find the radius, and it's a distance, and so I'm going to be using the distance formula. All right. Excellent. So my distance for my radius is going to be, I've got 2 points. I've got that point there, -3 and 4. I've got the point in the center, 0 and 0. That's the origin. That's the center of my circle. And the distance formula was this. It was the square root. And what did I do? I went the first x value minus the second x value. So I'm going to go -3 minus 0. I'm going to square that. And then I'm going to add, and I'm going to do exactly the same thing with the y coordinates. I'm going to go the y coordinate minus the other y coordinate, and I'm going to go and square that. Now, again, like we discussed when we spoke about the distance formula, I can do this in my head, but specifically when the answer isn't nice, definitely just take out your calculator, and let's be using our calculator. So I'm going to take out my calculator, which is here, and I'm going to go and move it to the left-hand side of my board, and I'm going to go put in what we have. So the square root of open brackets -3 minus 0, close brackets squared. I'm going to add the y's. I'm going to go 4 minus 0 squared. I'm going to press equals, and oh, cool. I've now worked out my radius, and my radius is equal to 5. Excellent. All right. So I'm going to go and write down my equation, and that's there what I've got. Now, is this right? Well, no. Remember, in our formula, what we discussed is that, oh, and let me go back to my pen, yeah. It has to be the radius squared. And so my answer is not going to be x squared plus y squared equals 5. My answer is going to be x squared plus y squared equals 5 squared. And so, in fact, I can leave it like that, but my equation is going to be x squared plus y squared is 25 and not 5. So please be careful there. We have to be very conscious of whether I'm talking about the radius or whether I'm talking about the radius squared. Okay, wonderful. So that's our first example. Let's move on to our next example. This example continues. It's question C. We've got our equation, which is x squared plus y squared is equal to 25. And they want us to say whether this point there, square root 21 and 2, lies on this circle. So is it there, or is it actually on my circle? So how do we do this? When we were talking about functions to start with, what did we know, or what did we figure out is that functions is always going to be about input and output, all right? So let's see if this works. So let's put this point in. What do we know? And let me choose a different color. Is my x value is 20, the square of 21, and so I'm going to put that into x squared. So I'm going to go the square root of 21 squared. I'm going to put the y value 2 into y. I'm going to go plus 2 squared. And what I want to know is, does this equal 25? Does it equal what it's supposed to equal? Because if it does equal what it's supposed to equal, then yes, it does lie in the graph. If it doesn't, then I know that it doesn't. All right, excellent. So let's go and calculate this. I can do this on my calculator, so let me take that out. Here we are. Let me move it. Oh, sorry. Where's my calculator? There. Let me move it to the side a little bit. What am I doing? I'm doing the square root of, I'm doing open brackets, the square root of 21, close brackets squared, plus open brackets 2, close brackets squared. And what do I get? I get that this is indeed equal to 25. And so what do I know? This definitely, square root 21 and 2 is a point on my circle. Wonderful. So we're going to be moving on to the next example. It says, determine the value of b if that point, b and minus root 3, lies on the circle. So this is exactly like what we did when we spoke about all the other formulas in analytical geometry, is we started by just going forwards, just drawing. And now what we're doing is we're working backwards. And I want to find something so that my equation is true. So what I'm going to do is, it says this point does lie on my graph. So this equation must be true. It's not like the previous question where we wanted to see, is it true? This is true. What I want to know is, what is b so that it is in fact true? And so let's do this. They tell me that this is a point on my graph. So this is the x value. So let's put that into the x value here. So what am I going to get? I'm going to get b squared plus that there minus root 3 is my y value. And so I'm going to go do that squared. And I know that that is true. Now, this is where we need to be super careful, is with that y value minus root 3, if I put that into my calculator, the answer that I'm going to get is minus 3. But it's not minus 3. And this is where you need to be careful, is what I'm squaring is the whole y value. I'm not only squaring the square root 3. And so whenever, and we discussed this many times, whenever we substitute in, I want to make sure that I'm substituting in brackets, especially if it's a negative number. All right? And so what I get is b squared. I'm not quite sure what that is, so I'm just going to quickly take out my calculator. Let's just make sure that we get this right. And I'm going to open brackets minus the square root of 3, close brackets, or sign popped in there, close brackets, square, and I get 3 is equal to 19. And if I solve for b, I'm going to subtract 3 on both sides, and I'm going to get b squared is equal to 16. And when I solve, I'm going to square root both sides, and I'm going to get b is equal to 4. Is that right? Is there only one answer? I don't know. Let's see if I were to draw this graph, right? So what is my radius? Well, my radius is going to be the square root of 19. So let's go back to my calculator and let's just see what is the square root of 19. Well, the square root of 19 is equal to, and let's press this SD button, is equal to 4,35 something. So if I were to draw this circle, this is what it would look like. It would have a radius of 4,35 something, right? And if I plotted minus root 3 is about minus 1 something, so that's my y value, there, minus root 3. Now, do you see that there's actually 2 points, there and there, that have a y value of minus root 3? And so this is where it's super important. This is what we need to remember, is that when we square root, I always need to put in the plus minus. I have to put in a plus minus. Why? Because here's an answer at plus 4, and there's also an answer at minus 4. And so let's just be very careful here. It's always nice to remember what the sketch looks like so that we can decide if there's 2 answers or 1 answer. But let's just remember that when we square root, I'm always going to get a plus and a minus. Excellent. So let's move on to the next question. The question says, given a circle with center 0, 0, so that's at the origin, that's at the center of the Cartesian plane. We haven't moved our circles yet. That's what we're going to be doing next. And a radius of the square root of 45. And they say, determine the possible coordinates of the point or points on the circle which have an x value that is twice that of the y value. Now, often with questions like this, the question is, where do I start? How do I know what to do? And often we don't really see the end. We don't really know how to start or where we must go. But let's start with what we know. So what I do know is that the equation of a circle is going to be x squared plus y squared is equal to r squared. Now, they've gone and told me that the radius there is equal to square root of 45. So let's just put that into our equation and see what happens. X squared plus y squared is equal to the square root of 45. Again, what's important is that I'm squaring that radius, and so it's going to be the square root of 45 squared, which is going to be 45. Cool, so I have my equation. So let's read the question. It says, determine the possible coordinates of the points on the circle which have an x value that is twice that of the y value. So I don't know what the x value is or what the y value is, but let's go and make up, or not make up, but let's go and name the y value a. So let's say the y value is equal to a. They've told us that the x value is twice that of the y value, and so the x value is going to be 2a. Right? So they've told me that the x value is twice that of the y value, and so if the y value is a, the x value is going to be 2a. So let's put these in. So I'm going to go 2a squared plus a squared is equal to 45. Again, this is so crucial. When we do this, when we ever substitute, we have to do that in brackets, because what am I squaring here? Here I'm only squaring the a, and what I want to be squaring is the whole x coordinate, which is 2a. And so if I do this, I'm going to get 4a squared plus a squared is equal to 45. Awesome. And so that means that 5a squared, now I can just solve for this, is equal to 45. A squared is equal to 9. and a is equal to, and again, remember we discussed this, is when I square root, I need to have two answers, and so it's going to be plus or minus the square root of 9, which is 3. But again, now we need to answer the question. They've said determine the possible coordinates of the points, so they actually want the coordinate pairs. Someone else used B, someone else used M, so I can't leave my answer as A because that was what I created. So what is A? A is the Y value, and so I've got 2 points. It's either going to be a Y value of 3 or a Y value of minus 3. And what is the X coordinate going to be? Well, the X coordinate is going to be twice that of the Y coordinate, and so it's going to be 6 or minus 6. Those are the 2 coordinates of the points that would satisfy this, where the X coordinate is twice that of the Y coordinate. Excellent. So we've got time for one more question, so let's jump straight into that. Our next question says, determine the radius of the following circle, and they've given me the equation of a circle, 3x squared plus 3y squared is equal to 27. Now, at first glance, this question looks quite straightforward, right? What did we say is that the radius was always going to be the square root of the constant, of the number. And so all I'm going to go do is I'm going to go square root 27, and is that right? Am I on the right track here? No. And this is where you need to be so careful, is if I gave you the equation of a straight line and I said 2y is equal to 2x plus 6, is the y cut equal to 6? No, it's not. Right? The y cut is only equal to the number if y is alone, if it's in standard form, if it looks like what it's supposed to look like. And so I'm going to divide both sides by 2, and I would get the y cut as 3. And so this is exactly what I'm going to do here, is I have to get it into standard form, and I'm going to divide both sides by 3, and what I'm going to get is that x squared plus y squared is equal to 3 squared. My radius is 3. So we were talking about circles, we were drawing circles, but all of our circles had the center right in the middle. Now, not all of our circles are going to have the center right in the middle. Here we can see there's the center of the Cartesian plane, but the center of my circle has moved. My circle has moved upwards and to the right. Not all of our circles are going to have the center at the origin in the middle of our Cartesian plane. That's what we're going to be talking about now. So we spoke about parabolas when we started this, and we said that the equation y equals x squared is going to have a parabola that looks like this. It's a smiley face, and it's going to have our turning point there, 0 and 0. But I don't know if you guys can remember from functions, but if I change the equation of this parabola and wrote it as y equals x minus 1 squared, can anyone remember what that minus 1 did? That minus 1 shifted my parabola to the right. And so if it was negative, it shifted to the right. If it was positive, it shifted to the left. And what this has done is it's shifted my parabola to the left. Now, the exact same thing happens with our circle. There I have a circle, center at the origin, radius of 3. There's my center. It's got a radius of 3 units. If I were to change the equation of the circle and I made it x minus 1 all squared plus y squared plus 3 squared, what do you think this is going to do to the shape of my circle? Well, isn't going to do exactly the same what it did, what that minus 1 did to the parabola. What this is going to do is it's going to shift my whole circle to the left. And everything is going to be shifted 1 to the left, including the x cuts. So the x cuts were at minus 3 here, and at 3 there. And what happened is it shifted 1 to the right, exactly like my whole circle shifted 1 to the right. So if we did exactly like what we did with the parabola, and I said x minus 1, all squared. What did it do to the parabola? Well, it moved the parabola to the right. Now, that's exactly what's going to happen to my circle. My circle is going to shift 1 to the right, the whole circle, including the x-cut. Where was the x-cut? Well, the x-cut was at -3 here, and now it's shifted to the right to -2. The x-cut was at 3 here, and it's now shifted 1 to the right, and it's now at 4. Now, as much as I can shift my circle to the right, I can also shift it to the left, I can also shift it up, and I can also shift it down. And so now the standard form of our circle is going to be this. It's going to be x minus a squared, where a is going to be the x-coordinate of the center. It's going to be y minus b squared, where b is going to be the y-coordinate of the center, and r squared is still going to be the radius. Now, this seems a little bit confusing, but let's talk about an example and see what this looks like. So let's go to the next slide. It says here, determine the coordinates of the center of the circle and the length of the radius. All right, so what I'm going to do is I'm going to take my circle that's been given to me and I'm going to change it into standard form. Once it's in standard form, then I can decide what is the x-coordinate of my center, what is the y-coordinate of my center, and what is my radius. So I know that my standard form is x minus a squared plus y minus b squared is equal to r squared. So I'm going to go and write this. Does everybody see that that needs to be a minus, but currently it's a plus? And so what I'm going to do is I'm going to go minus 2 squared, and this is going to be y minus 3 squared, and that there I'm going to write as the square root of 15 squared, exactly like we were doing with the questions previously. So does everybody see now, right, now that I've got it in standard form, that my center is at -2, well, the x-coordinate is -2, and the y-coordinate is 3. Now, what we're always going to remember is this. If it's plus, it always moves in the different direction. So if it's a minus, it would feel like it should move to the left, but it doesn't. It always moves in the opposite direction. So if it's minus, it moves to the right. If it's plus, it moves to the left. And similarly with the y value, a minus feels like it should move it down, but it doesn't. A -3 is going to move it up, and a +3 is going to move it down. And so that's perfect, because that +2, what did it do? It moved it left to -2, and that -3 moved it in the different direction. It moved it up to 3. Wonderful. So the next question says, determine the equation of a circle with center 0, 0, and a radius of 4 units. Now, that's straightforward. That's what we've been talking about. This is just going to be x squared plus y squared is equal to 4 squared, which is equal to 16. And so I'm just going to go and erase that and write it as 16. Now it says, if the circle is shifted 2 units down and 1 unit to the right, write down the equation of the shifted circle, right? So what did we decide? Is 2 units down, we always decided that it's going to move in the opposite direction. So down is going to be plus and up is going to be minus. And so 2 units down, what is down going to affect? Down is going to affect the y value, and right and left is going to affect the x value. So right is going to be negative. So it says 1 unit to the right, and so this is going to be x minus 1. And this is going to be y. Down is going to be plus 2 squared. And what happened to the radius? Well, nothing. It's exactly the same circle that's been shifted, and so the radius stays exactly the same, and it's going to be equal to 16. Wonderful. So we're going to be going to an ad break now. We're going to continue doing examples and talking about shifted circles. We'll see you guys soon.